Hello everyone, I am Kairosha, a fourth semester student of Masters in Construction Engineering and Management. I will be giving presentation on my DRP. Topic of my DRP is Bim-Integrated workflows using Power BI for project planning coupled with AI-based 4D-5D simulation under the guidance of Dr. Jyoti Trivedi, who is Senior Assistant Professor and Program Chair of MTech at SEPT University. The flow of the PPT would be: first chapter would be introduction, second chapter would be literature review, third chapter would be research methodology, fourth chapter would be data analysis, fifth chapter would be validation study, and sixth would be conclusion. Starting from the chapter 1, introduction. Background of the study. In recent decades, numerous industrial sectors have undergone a significant transformations in terms of product and process innovations. Digital technology, whereas, have been widely embraced across various domains to enhance productivity and quality. However, architectural, engineering, construction, and operations sector, which is AECO, has not witnessed commensurate progress in terms of quality, productivity, sustainability, leading to stagnation in overall productivity within the sector. Thus, the BIM stand out as a pivotal development contributing significantly to the digitalization of the construction sector, serving as an information technology framework for creating, visualizing, exchanging, predicting, and monitoring information throughout the life cycle of building facilities. Economic significance in Europe. The construction sector significantly contributes to the environmental concerns, responsible for 36% of carbon dioxide emissions, 40% of energy consumption, 55% of electricity consumption in the European Union. Consequently, achieving the ambitious 2050 climate neutrality goals involves a critical emphasis on reducing energy consumption, promoting building decarbonization, and initiating environmentally conscious practices from the conception phase of projects, as BIM stand out as a pivotal development over here. Also, BIM model integration with time and cost gives the 4D and 5D respectively. With accurate schedule data and robust cost estimation, one can monitor the project performance. By leveraging the collective potential of BIM and AI, artificial intelligence, construction stakeholders can streamline operations, boost productivity, reduce errors, and adhere to stringent safety standards, thereby promoting sustainable development and resource optimization in the construction industry. The need for the study. The construction industry is inherently complex, marked by diverse tasks, multiple trades, and often unforeseen design changes during the construction phase. Managing construction schedules effectively is crucial for successful construction management, serving as a bridge between master schedules and on-site productions. However, traditional methods face challenges in integrating utilizing disparate forms of information for effective look-ahead planning, particularly in context of building information models, where building information modeling has found diverse applications in management encompassing tasks. Tasks like asset management, data storage, model visualization, energy analysis, safety protocols, lifecycle cost analysis, and troubleshooting. The utilization of BIM not only facilitates convenient access to essential information but also enhances the simplicity of data modification. Throughout the building lifecycle, BIM ensures continuous access to updated information and model itself, contributing to seamless integration of information management process. To streamline the utilization and accessibility of this crucial information, the software employed for visualization and navigating model geometry and data must become inherently more useful, user-friendly. The proposed study aims to develop a generic information management approach that aggregates data essential for visualization, 4D look-ahead planning, 5D cost assessment using BIM. By integrating BIM entities, tasks, work sequences, resource data, cost data, and site progress information within a unified platform, this approach seeks to overcome the limitation of current methods. The ultimate goal is to create a robust foundation for look-ahead planning, offering a clearer understanding of construction process, resource allocation, and cost consideration. Moreover, recognizing the evolving landscape of all project management, the study incorporates advancement in artificial intelligence and Power BI. The synergy of human ingenuity with AI capabilities and the analytical power of Power BI is positioned as a transformative force in project management. By harnessing AI algorithms and Power BI tools, this study aims to empower project participants with enhanced decision-making capabilities, automated analysis, and the ability to foresee challenges in the construction process. Aims to address the following key objectives. First, optimizing BIM for project planning. Explore the untapped potential of BIM in potential project planning processes by leveraging its capability for 4D-5D simulation. Investigate how BIM can be integrated into Power BI to enhance project visualization, sequencing, and resource allocation. Second, usability and customization of BIM tools. Investigating the challenges posed by current BIM authoring and analysis platforms such as Revit and Navisworks in terms of user knowledge and skills, aim to enhance the usability of these platforms by utilizing customizing them based on specific needs of project managers, thereby facilitating their interaction with critical lifecycle information embedded in the models. Third, user-friendly visualization software. Evaluation and propose improvements to software used for visualization and navigating model geometry and data, emphasizing the importance of developing user-friendly tools that cater to the needs of project managers, supporting their effective interpretations of project-related data. Fourth, enhancing interpolation and data interpretation, examining how the customization of software tools can promote collaboration among project stakeholders, emphasizing the importance of presence of most relevant information to users. Fifth, supporting adoption of BIM integrated workflows. How the investigating factors inhibiting the widespread adoption of BIM integrated workflows and propose strategies to overcome these barriers, emphasizing the need for user-friendly interfaces and customized tools for encouragement of staff engagement and enable seamless access to the critical lifecycle information. Incorporating AI for intelligent project management, exploring the integration of artificial intelligence into BIM integrated workflows and Power BI for intelligent project management. Investigate how AI algorithms can enhance decision making capabilities, automate analysis, and contribute to overall success of construction projects. For scope of work, we will be going through a detailed examination of a building test case over here and will study its 4D look ahead planning and 5D cost forecasting within a BIM Power BI dashboard. Now, moving to the chapter 2, which is literature review. Building information modeling. BIM is defined as the creation of comprehensive model encompassing information about building throughout all phases of its life cycle. BIM serves as a digital representation capturing both the physical and functional characteristics of a facility. Over here, we are showed with a diagram of all the beam dimensions up to 70, whereas architects and engineers are more concerned with the 3D, whereas contractor and consultants are more concerned with 4D and 5D, and owner and facility manager are over 60 and 70. Diving deep into the 3D, 3D BIM forms the foundation of BIM process. It encompasses generating of digital model that accurately depicts the physical and functional elements of a building or infrastructure project in three dimensions, such as length, width, and height. The 3D BIM model consists of intelligent objects or components that have properties and relationships, enabling stakeholders to gain a visual understanding and conduct analysis of building elements in a virtual environment. While 4D BIM introduces the element of time into the 3D BIM model, it incorporates the construction sequencing and schedule information, allowing stakeholders to visualize the project's progression over time. With 4D BIM, the model becomes a time-based simulation, providing insights into the construction sequence, potential clashes, the project planning. 5D beam. 5D beam introduces the dimension of cost to the 3D and 4D beam model. It integrates cost data with 3D model and construction schedule, enabling stakeholders to visualize and manage the project's cost throughout its life cycle. With 3D beam, with 5D beam, the model becomes a dynamic cost estimation and management tool. 6D beam. 6D beam adds the dimension of sustainability and environmental data to the 3D, 4D, and 5D beam model. It involves the incorporation of information related to energy performance, life cycle analysis, and other sustainable of the buildings. 6D beam assists in making informed decisions regarding the project environmental impact and sustainability goals. 7D beam. 7D beam extends beam model to include data associated to facility management and operation. It integrates information on maintenance schedule, asset management, and other operational data to support the facility lifecycle after construction is complete. 7D beam aids in optimizing the building performance, maintenance, and facility operations. 2D BIM presents a 3D model plus time which gives us a 4D simulation. The prolonged duration of construction projects, known as the time overrun, stand out as a prominent and critical issue in the construction industry. This concern holds significant implications for construction cost as an extended project timeline invariably leads to increased expenses. For certain projects, this escalated cost may be irreversible. Time overrun is specifically characterized by a deviation between initially estimated project duration and the actual time required for project completion. Addressing this challenge is crucial for effective project management, cost control, and overall success in the construction domain. Here are some of the causes of time overrun, which is tradition of conveying contract to the lowest bidder, inefficient site management, contractors' financial problems, poor planning, scheduling, and estimating, managerial issues with subcontractors, insufficient work experience, resource allocation and management problems, inaccurate estimation of project duration, unskilled designers, and shortage of manpower. Similarly, for 4D, 5D simulation is a 4D plus cost. The success of any project is significantly hinged on effective cost management, as cost stand out as the most influential factor. Presently, business encounters numerous challenges due to inadequate cost management, resulting in projects frequently surpassing their assigned budgets. Cost overrun emerges when unanticipated expenses exceed the predetermined cost limit established during financial planning. It's crucial to distinguish cost overrun from cost escalation, the latter referring to an unforeseen increase in the budget attributed to inflation. Cost overrun are typically attributed to three primary reasons: technical issues, social political factors, human related aspects. Identifying and addressing these factors is imperative for ensuring successful project outcomes and financial stability. Some of the examples for factors affecting cost overrun are: under technical factors, lack of safety measures on site, changes in work due to design errors, irrational time schedule, financial restrictions of contractors; human related factors like improper management and supervision, lack of skilled manpower to operate special equipments, lack of proper coordination; social political factors like unfavorable political conditions, and other factors like obsolete construction methods, severe weather conditions. 4D BIM. The potentials of 4D BIM are: the utilization of 4D BIM model proves valuable at various stages of a project, offering significant advantages, particularly in initial phases when assessing project feasibility. Planning teams can seamlessly integrate 4D BIM into their workflows, enhancing the evaluation process for potential ventures. The project delivery team handling large and integrated projects, 4D BIM serve as an advanced project management technique. The integration of comprehensive information enables planners to swiftly develop precise project plans, drawing from a unified data source. The implementation of 4D BIM also presents an opportunity to eliminate or reduce factors contributing to the time overruns in projects, showcasing its efficacy as a strategic tool in project management. If 5D BIM is implemented, the potential outcomes of 5D BIM are: it includes the organization of an internal database encompassing pricing information, labor rates, HR data, and key performance indicators. The achievement of project scope is enhanced by leveraging visual data modeling capabilities. Real-time access to information is achieved once the model is created. Additionally, building data and personal information are stored in a designed database accessible to specific departments such as plants and machinery, billing, quality, etc. This comprehensive approach ensures effective communication, streamlined process, and accurate decision making throughout the project lifecycle. Intelligence, often abbreviated as AI, is a composite term derived from artificial, signifying something not natural or real, and intelligence denoting the capacity for reasoning, generating new ideas, perceiving, and learning. This multifaceted discipline encompasses various activities including designing computer programs for tasks such as speech recognition, learning, planning, and problem solving. There are three distinct categories of artificial intelligence: artificial narrow intelligence, artificial general intelligence, and artificial superintelligence. Over here, I have provided and a diagram, a mind map for artificial intelligence and its type. As we can see, artificial intelligence subfields of AI are machine learning, which is again divided into supervised learning, unsupervised learning, reinforcement learning, deep learning, while knowledge-based systems, computer visions, robotics, language processing, automated planning and scheduling, optimization are further bifurcations in artificial intelligence. In AI, illustrated in figure, is a discernible upward trend in the number of publications in the field of artificial intelligence since 1960s. During 1960s, the application of artificial intelligence was at early stages with only a handful of publications exploring optimization techniques. However, the years optimization has emerged as a prominent area of research interest within AI subfields for the construction industry, likely stemming from the industry's persistent struggle with low productivity levels. Notably, the research trend indicates a shift in focus from knowledge-based systems to machine learning and last detail of using BIM and AI. By synergizing the collective capabilities of BIM and artificial intelligence, stakeholders in construction industry can streamline operations, enhance productivities, minimize errors, and uphold rigorous safety and standards. This collaborative approach not only contributes to sustainability development but also optimize resource utilization within the construction sector. Additionally, it endeavors to people strategic recommendation and best people to guide stakeholders in leveraging this integration transformative potential for promoting sustainable, efficient, and safe construction practices. Chapter 3, which is research methodology. First methodology includes the collection of project details, followed by formation of BIM model, then Revit connector is used for uploading the whole model to the open source platform. Once uploaded is then Power Automation workflow generating inference using ChatGPT 3.5 followed by Power BI dashboard 4D-5D integrated with AI while the during all these stages parallelly formation of schedule including budget and actual cost exporting to Excel and further getting it into our automate workflow generating inference using ChatGPT 3.5, Power BI dashboard 45 integrated with AI. Moving to the chapter 4, data analysis. Very first step of data analysis is data collection. The process begins with the fundamental step of collecting project data, specifically ground floor and first floor structure drawings are utilized for generating the Revit model, while dates and cost are used to create the MSP schedule. Few of the things data collected during this study is material, resources, budget details, project drawings, cost details, and activities. The drawings are collected and are analyzed. Then Revit model was created from the drawings. AutoCAD 2D drawings are studied and levels and grids are set. Preparation of columns and shear wall was done. Preparation of beams and slab was done. Then clash detection was carried out, on which clash report was also generated, removing clashes and also getting the clash-free model. During data analysis, after the integration of data from the open platform for the model, the queries should be run in Power BI platform to get the data from the API. One can preview the data with the help of transform data stored in the form of record. Queries are run in Power BI to analyze the data and perform various tasks to get the result done. As shown in the picture, this is one of the picture of task and the data recorded in the record.
So, to summarize the whole DRP and to have a visual output for our DRP, I prepared a dashboard for this over here. I have selected one of the project, a residential high-rise residential building, and created a two-floor structural 3D model over here from Revit. This 3D model is directly fetched out from the Revit, and this MSP schedule has been created accordingly and is directly fetched out from the MSP file only. First of all, the first KPI was progress on site, which is showing the percentage of the progress on site. The total area shows the stuttering area, which is directly getting from the Revit model. Volume in cubic meter, which is directly fetching out from the Revit BIM model, which can be updated in just a few clicks from the Revit and the Power BI itself. The CPI and SPI are indicative perspectives of cost and time, which is directly connected with the MSP file. Once edited and saved and refreshed, then the dashboard automatically refreshes itself according to the MSP file. The model was further divided into different pores. On clicking particular pore, we can get the particular visualization of a flow pore, and it's all over dynamic data. If the earned value graph was also shown over here, which gives an idea to one about the earned value, actual value, and planned value on a particular date over here. The schedule presented over here is directly fetched out from the MSP schedule, which has a start date, end date, and particular activities like shown. If filled, the color changes over here for a actual work. AI is also integrated in this part of the dashboard where one can get the data or a graph or a number in just a few clicks or in just a few questions. Suppose if someone wants a volume for a October month, he or she has to enter and just click OK. We can get the total volume in a cubic meter for an October month. If someone wants a graph for an actual cost versus, you just have to click and select so we can get the particular cost graph with the date itself over here. Furthermore, the 3D model for 4D simulation, we have to just click over here to get more precise idea for 4D simulations. Over here, we can get a 4D simulation for a particular date over here. As we can see, we can get the particular 4D simulations and 5D simulations from the graph and the model itself. If someone wants to deep dive into the particular pour, he or she has to click on a pour ID and have to drill down to a particular pour where we are jumped on another screen and have a particular pour related elements over here. Over here also we get the progress on site KPI, total area related to this particular pour, total volume related to this particular pour, the daily PPC related to this particular pour, earned value graph for the pour, and all the activities related to that particular pour. Also, one is there is an added advantage over here, which is the responsibility or a resource we are uh, applying to that particular task. So, if number of resources are assigned to that particular task, or a number of responsible person is assigned to that particular task, we can easily get over here, click that particular person, and have that task like task related to that particular person over in the schedule over here. So over here I also created an 4D simulation in terms of differentiation of colors, which gives an idea for a different activity we have a different color. So this shows the curing of beam, formwork, reinforcement, concreting, curing. As shown in the 3D model, this is the whole visualization goes on. Over here also the earned values go on, and all these fields presented over here are can be set or can be changed according to one needs, one expectations.
Moving on to the chapter 5, which is validation study. Validation study of our project for a DRP. Many various experts are being interviewed and collected their feedbacks and created and general points out of their interviews. The dashboard is a powerful tool that empowers construction managers and stakeholders by enabling them to make informed, data-driven decisions. Through the use of 4D-5D simulations, stakeholders gain insights into future activities and associated costs, allowing them to take proactive actions. Real-time monitoring further enhances control over the construction process, significantly reducing the risk of delays by 75 to 85% and ensuring that the project stays on a track. The experts on average rated the dashboard at 8.5 out of 10 for its impact on the site and management levels. These integrations offer a vast area of insights and understanding of projects, enhancing overall project management. Additionally, 95% of the experts agreed that dashboard promotes clear communication and transparency within the system. As part of our TRP, which is chapter number 6, conclusion. was in the four parts. First, building information modeling is crucial in construction for enhancing cost management and project quality throughout the building lifecycle. Second, the integration of 4D and 5D beam with Power BI has proven beneficial in enhancing costing, construction planning, project management. Third, these analyses offer valuable insights and solutions that significantly enhance efficiency, accuracy, and overall success in construction projects using advanced technology. Fourth, this study focusing on automating the extraction and visualization of critical information from BIM models and schedule through the cost analysis, 4D and 5D simulations, and AI integrations. First, comprehensive 4D simulation representation is limited to specific aspects such as particular pore face for detailed task differentiation. Regular updates are required for lively updates when Excel and MS projects are connected with the dashboard. Compatibility issues with ChatGPT 3.5 integration with Power Automate hindered advanced AI capabilities in current setup. Future scope of work: enhance 4D simulation representation by exploring methods to represent different tasks with distinct colors, providing a more comprehensive visualization of project progress. Integrating ChatGPT 3.5 into dashboard for enhanced automation and advanced capabilities in the decision-making processes. Explore direct integration of Microsoft Project with Power BI through its web version of streamlined data connectivity and enhance project management insights. Incorporate more key performance indicators and tailor visualizations according to specific site requirements to improve dashboard effectiveness and relevance, providing stakeholders with actionable insights and facilitating improved project outcomes. Thank you.